So another nice trick to increase the training throughput is increasing the batch size. But are large batch sizes really always better? We will see the answer to that in this video. So based on this plot, we can see that large batch sizes improve the computation performance only up to a certain point. So if we, for example, make the batch size much larger than 1024, we see that we have a saturation in the performance gains here. So large batch sizes may be better, but only up to a certain point. Now, vice versa, when we decrease the batch size too much, it can actually hurt also the predictive performance as shown here. And this is specifically true when we use small batch sizes, for example, with batch norm. So far the bottom line is that making batch sizes larger is usually a good thing. Making them too small can actually hurt the predictive performance. However, note that there is also some literature out there that shows contradictory results where a smaller batch size can also be better in terms of predictive performance. And that is usually when we have a model, let's say, that suffers from overfitting. Using a smaller batch size can introduce some random noise that can help a bit better with the generalization performance of the model. And yeah, as I found yet in another paper, we can see that a large batch size is usually preferred due to computational reasons, but choosing a batch size that is too large can also, of course, hurt the predictive performance. So far we learned that a batch size that is too small or too large can hurt the predictive performance. However, within a range, if we choose a large batch size, it can actually help with the computational throughput. So now when we increase the batch size though, we have to also adjust the learning rate. Or in other words, the learning rate has to be carefully tuned. And there's a rule of thumb that we have to scale the learning rate linearly with the batch size. However, as we can see here, this rule also does not always hold. So we have to be careful when we change the batch size and then tune the learning rate accordingly. So when we use large batch sizes, there's also a nice trick called warm starting, where we are warm starting the training with a smaller batch size first, which can also help with the generalization performance. So to summarize, in this video we learned that large batch sizes can be good for computational throughput, and if we don't make the batch sizes too large, we won't suffer from predictive accuracy drops. And we will see how this works in practice in the next video in the code example.